Hi everybody. Today my topics is using inverse matrix to solve a systems of linear equations containing two or three variables. Let's move ahead to see. Here we'll take two equations. So one is 2x plus 3y equal to 4. Another is x minus y equal to 7. Now we have to write equation in matrix form. How it is? Like here I have x coefficient 2 and 1 and y coefficient 3 and minus 1. So using this coefficient we will try to write this coefficient as well this variable x and y vectors in multiplication, I mean product form. Which is equivalent to this one. It is nothing but we have to multiply this by this one. If we multiply, then we get this. Now we can write the simultaneous equation as this one. Like as I told, this part we can write like this in product form. So it is that, and in the right hand side these two constant. Basically these three actually are matrix form. Like A, we can name this matrix as A and this matrix as big X, I mean capital X, and this matrix as capital B. Now we can write in standard form. Already we have seen in previous slide why we put A and capital X and capital B. So the actually standard form is A multiplied X equal to B. So A actually square matrix, already we have seen in previous slide, and this X, it is the really the things we have to find the unknown element in terms of X and Y. So what we will do, we will multiply both sides of the equation, I mean Ax equal to B. This equation both sides we will multiply by inverse of A. So what it comes? It comes as this. Now as we know, A inverse A, it is identity matrix. A inverse A, it is actually identity matrix. So, and also there is condition if inverse of A exists. That is important point also. So how you know that inverse exists or not? we have to find the determinant of matrix A, and we already calculated and we found it is -5 and it is not equal to 0. So what does it mean? It means it is non-singular and inverse matrix. So capital X equal to A inverse B. We can write this as we got the proof that it is non-singular and inverse exists. So we write like this. Now here we have matrix, already we have this matrix. So now we have to find A inverse. How we will find it? Procedure is we have to write like this: 1 by determinant of matrix A, and these places we will this one, we will swap these two. We will swap these two and we will change the sign of these two. You see here, we swap these two, it means 2 we brought here and -1 is here, and these two elements we change the sign. As we know, determinant of A is -5, so we put the value -5 as well this, so we got this matrix. A inverse equal to this. Already we have this X equal to A inverse B. Now we will put the value of A inverse. So we put the value of A inverse, I mean in these positions, and B is the matrix of the constant. It is taken from the equations. So multiplying these two, we get this. This is the value of X. This is the vector of variables. So X equal to 5, Y equal to -2. So in clear format, we can write X equal to, so we will understand it well, because X actually we want these two variables X and Y. So this X and Y means X equal to 5, Y equal to -2. And we got. So the solution of that two equations, linear equations, is X equal to 5 and Y equal to -2. Let's three equations containing three variables. So here we got first equation. This one is second equation. This is third equation. Now we have to write equation in matrix form, because we have to take out this X coefficient, Y coefficient and Z coefficient in a matrix form. So we did, and also the x, y, z, these vectors, variables, and then we have to write after product, after multiplication. It is in this format. Now, simultaneous equation form we can write like this. First matrix, it is all coefficient of variables, and this is the vectors of the unknown variables, and this is the matrix. These all are matrix. This is also matrix, this is a matrix, this is also a matrix. It is 3 by 3, this is 3 by 1, this is 3 by 1, and this is actually coefficient, I mean not coefficient, it is actually constant taken from the right side of the equation, so it is constant. This is also a matrix. So we can put the name like this one matrix A, this one capital X, this one as capital B. So already we know that a standard form, already we got it in previous slide, Ax equal to B. Now our target is to do some multiplications for these equations by A inverse. So what we will do, we will multiply both sides of this equation by inverse of A, and we get like this. So it is same like two equations what we have seen here. Also A inverse A is equal to identity matrix. So identity matrix, it will be represented by I, and also there is condition if inverse of A exists. That is most important. We have to prove that. So first we will find determinant of matrix A, and we found that determinant is 22 and it is greater than 0. So it is non-singular and inverse exists. So X equal to A inverse B. Now here already we have this matrix, and the sign, it is according to the position of the element. So here what we will find? We will find the cofactor of A11. Cofactor of A11. This one. Cofactor of this. How we will find it? Minus 1 to the power 1 plus 1. It means I plus j. So position is 1. I mean row is 1. Column is 1. Because this is the position. So it will be 2. So it is even number. So it will be positive here. And 2 minus 6, but already minus, so 2 plus 6 equal to 8. This way we will find, and one thing I want to mention, whenever we take this one a11, so cofactor actually coming the cancelling this row and cancelling this column, so remaining is these 4 elements, these minors. So which sign it is cofactors, and we get 8. Same way we will find a12, then we will go for finding a13. Same procedure we will follow. Then we will go for finding a21, this position. So once we get these 3, we can, this 3 value we can put here in this matrix. 8 minus 5 minus 1 and minus 2. 8 minus 5 minus 1 minus 2. So we have to put like this. This is actually adjuvant matrix. So remaining we'll do in next. Like here A22, we got 4. A22 means these positions. I mean A22. Cofactor we are finding. So A23, it will be these positions. Then we are finding A31. Then we will go for finding A32. Then remaining is A33. So we got all the values because A33 means these positions. All cofactor we got. So now we can complete the adjugate matrix. Remaining all value we put like 5, 3, 4, minus 8. Already all are here. So in previous slide we have seen determinant was 22 and adjugate matrix already we have seen in the last slide. We got this one, and now we need to find transpose of adjugate matrix. It will be called adjoint matrix. So what is transposing? It means this matrix row, it will be column here. This second row will be column here. This third row will be column here. So this matrix will be called adjoint matrix. It is needed for us to find the A inverse. I mean inverse of A matrix. How we will find it? We will take adjoint matrix A divided by determinant A. So already we got determinant 22, 1 by 22 because it is division, and this is the adjoint matrix A. So multiplying this we get this value. Now we will use this. As we know, x equal to A inverse B. So x equal to this, we remember A inverse, already we know the value this matrix, and this is the constant taken from the equations. This is B matrix. Multiplying these two, we get this value. This is X matrix. It means it is the value of X, Y, and Z. So we got the value of the three variables. So in clear format, X, Y, Z. So this is the value 3, 2, minus 3. So X equal to 3, Y equal to 2, Z equal to minus 3. That is the solution. So I wrote here X equal to 3, Y equal to 2, Z equal to minus 3. That's all for today. Thanks for watching.